In this presentation, we will, we will discuss the path to creating, delivering, and assuring services using the DIME computing model. It exploits the parallelism and high bandwidth available in the new generation of microprocessors. The DIME computing model itself is described in my book, Designing a New Class of Distributed Systems, published by Springer. In this presentation, we will focus the application to develop a DIME network aware Linux, Apache, MySQL, Perl, PHP, Python cloud. I will describe now how we have used process virtualization to create a network of DIMEs implementing Linux, Apache, MySQL, and PHP based web service with auto scaling, self repair, and end-to-end transaction FCAPS management without using Hypervisor or other resource virtualization and management frameworks. We transform the Turing machine implementing von Neumann computing into a distributed intelligent managed element which implements the non-von Neumann managed Turing machine. The control network is an overlay over the current von Neumann serial computing network. Each Linux process is then controlled by the FCAPS management, and essentially we convert every Linux process into a managed computing element that provides fault configuration, accounting, performance, and security management. The control network allows to set up the various parameters that are required for executing the process, and it can start by loading and executing the process executable. The control network also allows you to stop the computing machine at any time you desire based on policies, and you can also restart, for example. So this picture shows a simple service being controlled, loaded, and executed. There are three benefits derived from the DIME network architecture. One, it provides fault configuration, accounting, performance, and security, visibility, and control at Linux process level, eliminating the need for virtual machines, hypervisors, and the associated management complexity. Number two, it decouples the services management from infrastructure hardware management. And number three, the signaling control network allows end-to-end distributed transaction FCAPS management, both in the intercloud and intra-cloud environments. This picture shows the screenshot of how to create a DIME-aware Apache application and DIME network-aware PHP modules. This picture shows the drag and drop screen for creating a DIME network where multiple Apache applications are configured as primary and the secondary servers, and also a DNS which assigns the primary and the secondary list to create a computing cloud of Linux and Apache servers. This screenshot shows the DNS DIME with the list of primary and the secondary Apache dimes in the network. The users can access the application by going to the site apachemarco.org. This screenshot shows the configuration manager performing both the fault management and performance management at runtime. This screenshot shows the signaling network in play that allows each dime to inform its status. For example, this dime is configured as a backup. This screenshot shows the secondary Apache also is dime aware and is controlled by the configuration manager to be the second backup. Each component is encapsulated as a dime, and the application or service running in the mice is controlled by the FCAPS manager. The fault and performance information from each dime is collected through the signaling channel and is utilized by the end-to-end dime network management infrastructure implemented here in the administration panel. The policies are implemented by the dime network configuration manager, including the supervisor, fault manager, performance manager, accounting manager, and the security manager functions designed to execute policy implementation workflows. The DNS provides the primary and the secondary list of the Apaches encapsulated in different dimes with different addresses. When the primary dime fails, the secondary is replaced. This screenshot shows the user application accessing an MySQL database at an IP address 10.0.0.17 via a URL which is apachemarco.org. The application accesses a record from the database, increments it by 1, and stores it back while it is printing the current record on the screen. As you can see, 425 is the current reading, and it has stored 426 back in the database. The next two screenshots show the DNS configuration before and after. Here you can see before the failover, auto failover occurred, the apachemarco.org is at 10.0.0.11. When the failover occurred, it has changed now to 10.0.0.19, and the user application now, you can see, has changed the IP address to 10.0.0.19, although it is accessing the URL apachemarco.org. You can also see the counter has been incremented when it read the MySQL database. This picture shows the performance characteristic, which is the response time, as a function of the request. As you can see, as the performance degrades, we can add additional dimes and control the response time. This picture shows that we can dramatically increase the performance by improving the response time as a function of the number of requests by adding 2 dimes instead of 1 dime. It is interesting to look back at what von Neumann said in his Hickson Symposium in 1948. It's very likely that on the basis of philosophy that every error has to be caught, explained, and corrected, a system of the complexity of the living organism would not run even for a millisecond. We believe that the dime computing model, by introducing the managed Turing machines, brings the cellular architectural resiliency to computing infrastructure. I have two video links here which show the parallax operating system and also dimes in Linux approach. Thank you. This table shows the comparison between conventional computing, cloud computing, and dime computing. In the case of conventional computing, the physical server is the base computing unit, whereas in a virtual cloud computing environment, virtual server becomes a base computing element. In dime computing, in the process based virtualization in Linux, a process itself is a base computing unit, and in parallax, a core becomes a computing element. Now, we have listed here various characteristics and the differences between the three computing models. As you can see in the last row, the management latency is different in different computing models. The dime computing model essentially provides real-time management where the service transaction time and the service management latency are approximately equal. This picture shows the evolution of pots, pans, and distributed computing. Obviously, the AT&T Bell Labs contribution to the first cloud, which was the voice cloud, was to connect billions of users using plain old telephone service POTS. With the introduction of the internet, billions of devices were connected and provided a platform for pretty amazing new services, the PANs. Now we have a new opportunity with the distributed clouds where the server is a cloud and a federation of clouds will provide connecting services to trillions of managed and distributed services. Thank you.